I think we talked about this, but maybe we didn't. The test is in two parts. One part, no calculator, one part with calculator. So, and the majority of it is without. So the bigger chunk is without. So keep that in mind. And you know, I mean, obviously if we're doing regression, we need a calculator, right? I mean, there are certain things we need a calculator. Most of the people. All right, so I want everybody focusing on 1.5 now for a little while. At the end, I'll take any questions about the tests that you might still have, but right now we're focused on 1.5. So, right off the bat, it says find this. Does anybody know what that means? The inverse. This means the inverse of F. So, please don't think of this as an exponent. It's not. It's the notation for inverse. Okay, this is the notation for inverse. Now, we're going to talk about this two ways. Because intuitively, what inverses do is they undo each other. So if you think about function f, f takes a number and adds 2. So if its inverse is going to undo that, what do you think its inverse is going to do? Subtract 2. Yeah, it's not brain surgery, folks. The inverse is going to subtract 2. Think about it for a minute. If you put, let's say we were going to find f of 5. Okay, what's f of 5 going to equal? 7. Now, what happens when you take that 7 and put it into the inverse? What does it do to that 7?
Subtract.
Subtracts 2 and turns it right back into 5. So these guys undid each other. They undid each other. Now, for simple ones like this, I mean, that's so easy. Algebraically, we find inverses, and you'll remember this from last year. Take your original problem, remembering that f of x is the same as y. Switch the variables. Do you remember doing this? Switch the variables, and then get y by itself. Did we end up with what we thought the inverse was going to be when we did that? So, if you can't do it in your head, or want to do it in your head, you can always do it algebraically. Switch the variables, just flip-flop them, and then get y by itself. And that's how you find the inverse. So, let's try the next one. Here's the original. Just for fun, anybody have a guess about the inverse? Anybody want to guess what the inverse is? All right, let's figure it out then. So take your original and switch the variables. All right, see what I did? X becomes y, y becomes x. Now, start solving it for y. So we'll subtract 1 and divide by 3. So my inverse is x minus 1 over 3. Did everybody follow those steps? Okay, let's talk about it for a minute. Pretend I'm a number and you put me into this function. What happens to me? I get multiplied by 3 and have 1 added to me. Okay? So functions are like machines. You multiplied by 3 and you added 1. Now, put me in reverse. What has to happen? If you put me in reverse, we have to subtract 1 and then divide by 3. And isn't that exactly what the inverse did? They undo each other. They undo each other. All right. So far, so, oh no. Look at this next one. Okay. No way can I do this one in my head, so I'm gonna have to work it out. That's okay. What are my steps? Step 1, flip-flop them, so x equals 2y minus 3 over 5y plus 1, okay. Then what do I need to do? I need to get y by itself, right? So this is gonna take a little more time than these easy ones did. Jake, what were you saying? How do I start this? Get this guy over here. In other words, get rid of the fraction. Now, do keep in mind that when you do that, this becomes a distributive over here. So I'm going to have 5xy plus x equal to 2y minus 3. Now, I want to caution you about something. I always have kids, don't write this down, but I always have kids say, okay, I'm going to add 3 and divide by 2, and that gets y by itself. What's wrong with that? That is wrong. There's still another y in the problem. Okay, so that's not how we're going to do it. That is not how we're going to do it. Any idea how we are going to do it? Nyla?
Add 3 and subtract 5xy to get both of the y's on the same side.
Get both of the y's on the same side. Did you hear what she said? So, she said, I think go that way, or this way, I don't know, it doesn't make any difference, we gotta get the y's on the same side. So, 5xy minus 2, oh, I see why you went that way, Nyla. I would have a bunch of negatives, it doesn't matter, but, yeah. So, get both of your y's on the same side, either side, doesn't matter. So, if you wanna subtract your 5xy and add your 3, you'll have fewer negatives than I will at that point, for sure. Now what? What did we do that for? What did we get those y's on the same side for? Allie?
So now you can divide 5xy and then the other side divides x. Or is that wrong?
Well, I'm going to divide, but before I can divide, I'm going to factor first. Can I pull that y out?
Oh, yeah.
And when I pull that y out, now instead of having 2 of them, which was the problem, right? The issue was there were 2 y's here. Well, now there's only 1 because I factored it out. And then I can divide. Nyla got this, which is exactly the same thing. It's exactly the same thing. Doesn't matter which one you have, they're the same. And that's your inverse. Any question about that? A little bit bigger problem. The steps are the same. We switched the variables and then got y by itself. It just took us a little while to get there. Anybody have a question about it? No? All right, what do you think about this one? Well, I'll switch the variables, I can do that. Now what? Square both sides. So then I would have x squared equals y minus 4. And then what? So y is going to equal x squared plus 4. Everybody good with that? I want to talk, you're exactly right. You're exactly right. I want to talk about, though, a little limitation we have to add to this. So, good test review. What shape is this right here? The original problem. What shape is he? Oh, no. He's not a parabola. What is he? He's your square root function moved over 4. So would you agree with me that that is a picture of the original? Okay, now let's graph the inverse. What's this look like? That's a parabola up 4. Now, does anything about this situation bother you at all? Remember, these are inverses, so they undo each other, which means if you plug 6, I'm making these numbers up, if you plug 6 into the original, you get 10, and then if you plug 10 into the inverse, you get 6 back again. Remember that phenomenon we looked at? What does that sort of imply? Doesn't that sort of imply that all the points of this have to be the backwards points of this, and vice versa? So now tell me what's wrong with what's wrong with this situation? What's this point right here? Maybe -4 or 6 or something? So what would be the inverse point then for that? 6, -4? Are there any negatives in the original problem at all? And if there aren't any negatives in the original, aren't these all plus points, positive? Then that means your answer has to have, your inverse has to have all positive points. So we can't look at this whole thing. We can only look at this part of it right here. Right? So I gotta come down here and I gotta say, okay, this is my inverse so long as x is greater than or equal to 0. That isn't gonna happen with shapes that are, I think of them as complete. So like if you have a line, that line goes forever and ever in both directions. So its inverse is gonna come out just fine. But this is not a complete picture. Do you see what I mean? It doesn't include everything. And so the inverse can't include everything either. Is it tricky? Yes, it is. You gotta keep your brain turned on. So this is the inverse with this little added piece. All right, what in the heck? What about E? It's not even an equation. What do you think the inverse in E is going to be? Yes! So it would be 2, 1, 4, 3, 6, 5, and 2, 7. Because guys, what do inverses do? They undo each other. They switch X and Y. That's what happens when you have inverses. Look at problem E again. Is E a function? Is the problem in E, written on the paper there, my handwriting right there, is that a function? Why? No X's are used twice. That's what a function is. Passes the vertical line test. No X's are used more than once. Now what about its inverse? Is that a function? No, because we've got a repeat here. Wait a second. What caused that to happen? What in the original problem made it so the inverse wouldn't be a function? 2 y values that matched. 2 y values that matched. So if I have a shape, let's just take a parabola. Are there two y values that match on this parabola? So the parabola itself is a function, but its inverse is not going to be a function because when I flip-flop these ordered pairs, the x's will repeat. This brings us to the idea of the horizontal line test. Now, the vertical line test tests whether you are a function or not. The horizontal line test checks to see if your inverse will be a function. If you cross the horizontal line more than once, then your inverse will not be a function. Does that make sense to you? Because you got y's repeated? If you have a function that passes both tests, so, let's say this one right here. Does that pass horizontal and vertical? That function is called 1 to 1. If a function passes both tests, it is 1 to 1. So 2a is 2a a 1 to 1 function? Nope, doesn't pass the horizontal line test. What about b? Nope, doesn't pass the vertical line test. Well, I just did c. C is a yes. What about d? Yes, it is also 1 to 1. Very, very good. Everybody okay so far? All right. This is good test review too here, this next problem is, because in order to prove that things are inverses, now kids, we just spent some time, I know you haven't really practiced yet, but we just spent some time finding inverses, talking about how to do it, how to find them, switch the variables, get y by itself. Somebody has already done that and has claimed that these two are inverses of each other. And we are going to try to figure out if that's true or not. Jake?
I think it is.
Jake's eyeballed it, he's thought about it, he thinks it is. And as much as we love Jake, the fact that he thinks it is not proof. That is not our proof, okay? So please don't write yes, because Jake thinks so. That is not how we're going to do this. How we're going to do this is, we are going to build two compositions. This is on your test tomorrow, not the inverse part, but the composition part, so it's good practice. We are going to build f of g of x and g of f of x, and something special is going to happen. So, doesn't matter which one you do first, I'll do this one first. This means you have to do this tomorrow on your test. Make sure you know how. This means we take g and plug it, so we take g and plug it in to the f function. So what will that look like? 3 x minus 2 over 3 plus 2. G is going into f. Are you with me? Now, what happens? Let's clean this up. Don't these cancel? So we have x minus 2 plus 2, which is x. If they are inverses, then both of these compositions, everything has to cancel out and leave you with just x. So let's see if it works over here. This means put f into g. So 3x plus 2 minus 2 over 3. Does everything cancel out in that one? and we would just X. I think so. Don't those cancel? And we would just X. That is your proof. To prove that things are inverses, you build the compositions. And in both cases, you gotta do both of them, and in both cases, everything cancels and leaves you with just plain X. Jake?
You mean you do it like that every time?
Uh-huh.
Okay, because like, that one I just thought about it like, how you said like a machine and like just
Yep.
go backwards.
Totally get it,
Alright.
absolutely get it. But if we're gonna do a proof, it's kinda like in geometry, you knew those two triangles were congruent, but you had to go through all the process,
Yeah.
that's what we have to do.
Oh, yeah.
Alright, why don't you just take a minute, since this is on the test, this skill, not the inverse part, but just the composition part. Why don't you try building the two compositions for part B? So remember, that means you are doing, in either order, F of G and G of F. So, pick one. Did it work? Sure looks like it did. I thought this was not gonna work out, but it sure did. Now, I hate to beat a dead horse, but this is tomorrow's test. You gotta be able to do this. So, let's just look at this one. This says F of G of X. So G, whatever G is, gets plugged into F. So this goes right there. So 2 minus the 7 over 2 minus 7 over 5. You have to be able to do that tomorrow, right? Okay, we're ready.
What information you want us to do with that one?
That's it. All this work is the answer.
Oh, just the word.
The fact that you got X on both of them, that's your answer. That's your proof. That's what has to happen. Okay? Alright, one more and then we're gonna stop. Okay, we're gonna do one more. Go ahead and get your calculators out. We're gonna need them.
No.
Alright. Last problem, then we'll review. We gotta get through this stuff. Alright, so here we go. These equations look weird to you, because we have our x and our y, but then we got this other variable thrown in there, t. These are called parametric equations. Parametric equations. And t, the letter t, is called the parameter. These equations are used a lot, like in physics, when we're talking about moving objects, because often t will stand for time. So what these equations are telling me is, what is my x coordinate at 1 minute, and what is my y coordinate at 1 minute? So it's a way of identifying a position in terms of time. Now, parametric equations can be used for other things also, but that is a real common way that they're used. So, basically what you can think about here is, what is my point? What is my location on the graph 3 seconds ago when t is -2? So where was I 3 seconds ago? Well, my x was -2, would you agree with that? And then my y was 3. I checked my arithmetic there. And then 2 seconds ago, same thing. Is that one 0? All I'm doing is plugging in t values, guys. Plugging in t values. Hopefully correctly. I'm not sure about that. I think I messed that up. This should be it. So I gotta remember I'm plugging in 3 for t. Alright, did I mess any of these up, guys? Did you get anything different than me? Totally possible. I caught a couple of my mistakes, but there could be more. Those look okay? So I'm gonna go ahead and plot those real quickly, plot these points. So -2, 3, -1, 0, 0, -1, 1, 0, 2, 3. What shape am I getting here? It looks like it is going to be a parabola, doesn't it? Well, let's graph it on our calculator and see. Alright, I need you to go to mode, right where my finger's pointing right there. It says mode. And I need you to go down. For me, it's the 4th row down. I have function highlighted right now, but I need PAR highlighted, parametric, because we're going to graph parametrically. Okay, so everybody's highlighted parametric. Then I want you to go to zoom standards, or zoom 6, so we have a regular window. Take out any equation you might have in there. All right, now go to y equals. What's different about y equals now? Now you got t's. So x sub 1 is going to be t plus 1. Oh, that's x. Mrs. Ford, where's t? T is your variable button. It's where x is, only now it's t, not x. Right here, right? Right there. So x is t plus 1, and y is t squared plus 2t. Now go ahead and hit graph. And I don't know what you see, because there's one more thing we might need to adjust. Did you see a parabola? You saw part of a parabola. Okay, go back to your window. And it needs you to tell it what t's to plot. So our t's are going from -3 to 3. So you might go a little bigger than that, -5 to 5 for your t's. Now do you get the whole parabola? In window for the t max and min. Because if you're in parametric mode, when you go to window, it's asking you for x, y, and t. Okay? Now, before we got one more thing to do. We'll answer some questions next time, but before we, because we're gonna do another one. Before we do anything else, I want you to go back to mode. And I want you to change your calculator back into function mode. So go down and highlight FUNC, because tomorrow we'll have all kinds of issues if we're trying to graph in parametric mode tomorrow. We don't want to be there. All right, so we're back in function mode. All right, so the calculator down. We have to do letter B, and then we'll be done. Letter B says, write the equation of that parabola. Kids, that is so easy to do. Look at this x equation. Would you agree that t equals x minus 1? Take that and plug it in here. So now you'll have y equals x minus 1 squared plus 2 times x minus 1. Get t by itself, and then substitute that in here. So what variables are you left with? Which is a direct algebraic relationship between x and y. That means write an equation that has x's and y's. Now, is this going to be a parabola, guys? When you, we can do all this and work all this out. Is this going to be a parabola equation? In fact, doesn't look exactly like we would expect it to look. Isn't this a parabola drop down 1? And isn't that what happened when you graphed it on your calculator and when I graphed it by hand? Pretty cool. All right, I know there are some questions. We'll get to those. Next time we'll do another parametric problem. But right now, I want to take a couple minutes. Does anybody have any burning questions about some kind of concept that we have to do tomorrow? Ally, don't hold your head, it's not that bad.
No, I'm good.
Amanda?
On the homework 1.4, can you do C? Let me see.
All right, Amanda got her homework back. And she said, I got a question about this problem, which is definitely going to be a test question. The two functions are these two. And we are building a composition, just like we were doing earlier, but now we're doing it with a number. So this means plug 2 into H. So if I I plug 2 into h, I'm going to get the square root of 3. Then I take the square root of 3 and plug it into g. So g of the square root of 3 will equal 2 square root of 3's squared. And the square root of 3 squared is 3 times 2 is 6. So the answer is 6. Amanda, I looked at your answer there, and I want you to recognize something. Are there any x's in this problem? In the problem itself, no x's. So when you write your answer, no x's in the answer.
Okay.
Okay? If there's a number in the problem, your answer is going to be a number. All right, anybody think of anything else? Turn back all the papers that I had. So we're all totally,
Can you do the 2 above it?
so B uses f function, so here are h and g, and then f is 3x minus 8. And B says just divide f of x by g of x. So just put 3x minus 8 over 2x squared. That's it. That's the answer to that one.
Oh, okay.
And then f of x minus g of x, same thing, only we're subtracting. So we'll take our f function, 3x minus 8, and subtract our g function, which is 2x squared. Probably should write that in descending order. Not the end of the world if you don't, but that's fine. Notice, x is in the problem, Amanda, x is in the answer. All right, anybody else? Life is good. Tomorrow's test day. Be ready.
Do you have all this out?